can you hear me? Can you please reply if you can hear me? Hi. Am I audible? Can you hear me? Okay, so just confirm if you can hear me. No, this is the first time I'm trying this. Yes? Okay. Okay, so let's do some basic MCQs, okay, which I have got 15 questions from chapter 1 and 15 questions from chapter 2. Okay, can we go on? Yes. So the first question, okay, just take your notebook, okay? I want you to solve and tell me the answer, and I'll also be doing it. Okay, these are very, very good MCQ questions taken from previous years CBSE board papers. Okay. Oh, am I not audible? Can you confirm? Because Deepu says I am not. Sai Kripa, can you please confirm if my voice is clear? Am I not audible? Because can you please check once? I can hear you. Okay, fine. I think then yes. Okay. Thank you so much. Thank you for confirming, because this thing of going live it requires a couple of tools, but I'm not using any of them. I'm directly going live. So thank you so much for confirming. Can we start? Have you got your maths notebooks near you? Yes, I can hear you. Thank you so much for confirming, Deepu. Thank you. Can we start? So the first question for the day is this. Let me know if you can see the first question. Yeah, which of the following cannot be the unit digit of 8 to the power n, where n is a natural number? So the options are 4, 2, 0 and 6. Can you do it? So you are asked which of the following cannot be the unit digit of 8 to the power n. Okay, let me do it. What is 8 to the power n? Let me write it for you here. So you are asked which of the following cannot be. Okay, so you have to write what is given and then factorize it. Okay, so it's 2 cube, right? 8 is nothing but 2 cube whole raised to the power n, which is nothing but 2 raised to the power 3n, right? So in order for 8 to the power n to have 0 as a unit digit, what should be the factors there? In order for a number to end with 0, always make sure you stick to this. You already know a fact that, right, in order for a number to end with 0, okay, if a number has to end with 0, what are the factors it should have? It should have 2 and 5 as a prime factors. But you cannot see, it's only 2 that is there. You cannot see 5 as a prime factor. So 0 cannot be the unit digit of 8 to the power n, right? Okay, so 8 to the power n cannot end with 0. Why it cannot end with 0? Because it has only 2 as a prime factor. It does not have 5 as a prime factor. So what is the answer? The answer is C. Okay, so the answer is C. Is it clear? Okay, so how should you, in case if you're asked to elaborate, how should you write? A to the power n is nothing but 2 raised to the power 3n. Okay, all the factors of a to the power n, it will only contain 2. So for example, for n equal to 1, right, 8 is equal to 2 cube. For n equal to 2, 8 square equal to 2 raised to the power 6, 3 into 2. So for any value of n as a natural number, 8 to the power 3 will only contain 2 to the power 9. So it will only contain 2 as a prime factor, and 0, it cannot be 0. Okay, 8 to the power n can never end with 0 because it does not have 5 also as a prime factor. Is this clear? Is this clear? Yeah, correct. Let's move on to the next question. Can we? I hope you have done. Sai Kriba, I think Nandana is also here, Darshana is here. Yes, okay. Diba, thank you so much for joining, all of you. So is this question clear? Okay, probably we would have seen a similar question, not as an MCQ, but probably for a 2 or 3 marks. But this question, most of the questions that I have got for an MCQ is generally not seen as a 1 mark question. Okay, so one of you are asking, if they ask which of the following can be a unit digit of a to the power n, probably you have to check for a to the power 1, a to the power 2. Okay, so you'll definitely have 8, 6, right? You have to do it for the first 4 n numbers and see. The option will definitely have all of the above as well, if that was the question. So let's move on to the second question of the day. Yeah, here. If x is the LCM of 4, 6, 8 and y is the LCM of 3, 5, 7, p is the LCM of x and y, which of the following is true? Can you do it? So what is given here? LCM of 4, 6, 8 is nothing but your x. Find out what is x. And then the LCM of 3, 5, 7. Remember, all the 3 are prime numbers. And whenever you have to take the LCM of prime numbers, it's always a product. Okay, find the LCM of 3, 5, 7 and that will be your y. Can you find out what is x and y? Okay, so LCM of 4, 6, 8. So you will have to do the prime factorization of 4. So 2 square, 6 is nothing but 2 multiplied by 3, and for 8 it is 2 cube. So whenever you have to take the LCM, you have to take the highest power of all the prime factors. So highest power of all prime factors. So 2 cube multiplied by 3, which is 8 into 3, that is 24. So your x is 24. Find out what is y. Find out what is y. So LCM, we have just found out x because you are calculating the LCM of 4, 6, 8. Find out what is y. For y, you have to just multiply all the 3 prime numbers. So 3, 5 and 7. All the 3 are prime numbers. Just get me the product of it. So you have 15 multiplied by 7. So your y is nothing but 105. Are you getting it? Okay, so you've got the options also. And then you have to get LCM of x comma y is equal to your p. So what is the LCM of 24 comma 105? What is the value? Yeah, LCM of, x is 24, y is 105, and the LCM of 24 and 105 is your p. Then which of the following is true, it's asked. So find out the LCM for 24 and 105. Okay, and 105, Okay, so 24 I can write it as 2 cube multiplied by 3. 105 I can write it as 3 square multiplied by 7. So the LCM would be 2 cube multiplied by 3 square multiplied by 7. So 8 into 9, 72 into 7. Are you getting 50? What are you getting? I think I have made them 9 8 are 72. What are you getting actually? LCM of 24, am I made? 2 cube into 3. Okay, I've made a mistake here, right? Okay. So you will not have 3 here, just a minute. Okay, it will be 5 here. So 5 sevens are 35. And here you will be having 3 into 5 into 7. 3 into 5 into 7. So you will be getting, what will you be getting? Multiplied by 5 as well. So 24 multiplied by 35. Let it be as such, 24 multiplied by 35. Okay. So LCM of 24 and 45, you are getting 24 multiplied by 35. Don't find the product, let it be as such. What is 24? 24 is our x. So x multiplied by 35. So which of the following is true? P is equal to, what is P equal to? 35 into x. The option is A. Okay, you don't have to multiply and find the product. Is this correct? Are you able to understand? P equal to 35 into x. Okay, because 24 is nothing but your x. Is it correct? Is it clear? Yes. Okay. Can we move on to the next question? Yes, okay. Sai Kiba, have you got? So please be very careful when you are doing the prime factorization of the numbers as well. Okay. The next question for the day. Yeah, this is something which we have already done. Let's do it. HCF of 98 and 28 is m. LCM of the two number is n. Find the value of n minus 7m. First of all, let us do the prime factorization of 98. Do the prime factorization of 98. Get me the value for the LCM and HCF. So, okay, so 98 is nothing but 7 square multiplied by 2, and for 28, so 14, again 2 7. So for 28, the prime factorization is 2 square multiplied by 7. So the LCM is nothing but the highest power of all the factors. So 2 square multiplied by 7 square. So 4 multiplied by 49. 196. Okay, so LCM is 196. So here, what is LCM? It is given as n. Okay, HCF is nothing but the lowest power of each of the common factors. So the lowest power is 2 into 7, which is nothing but 14. And 14 is your HCF is your m. N and m we have found out. So all we have to do is just substitute. N minus 7m is asked. What is the value of n? 196 minus 7 multiplied by 14. Do it and tell me. So 196 minus 98, which will be 98. So the answer is, what will be the answer? 98. C, option C. Okay. Yeah, 98, it's right. Very good if you're getting it. So this class is just a revision of what we already know. Can we move on to the next one? Yeah. Okay, 98 is the right answer. Now let's move on to the next question. Yeah, this is again a very, very good question. Find the greatest number, the greatest number which divides 70 and 125, leaving remainders 5 and 8 respectively. The minute you are asked the greatest number which divides, okay, what does it mean? It means find the biggest number which can divide both 70 and 125 perfectly, some two numbers. But in order to get those numbers, you will have to first subtract the given numbers from its remainders in order to get the actual numbers. Okay, so the first thing to do is write the given numbers 70 and 125, subtract it from the remainders, that is 5 and 8 respectively, and get the actual numbers 65 and what is 125 minus your 8, 125 minus 8, 117. Okay, so you have to find the biggest number or the largest number which can divide 65 and 117 perfectly. So it cannot be a bigger number, it will definitely be a smaller number. No, see, what you are asked is find the greatest number which divides two numbers leaving remainders 5 and 8. First of all, we have to find the actual number. So 70 minus 5 will give us 65. 125 minus 8, always see, just an example. Suppose if I am dividing 40 divided by 3, for example, okay. So 3 ones are 3, right? And if you subtract 3 3s are 9, okay, right? If suppose 3 is the number which can divide 40 leaving the remainder 1, what does that mean? If I subtract 40 minus 1, right, I will be getting 39. So 39 can be perfectly be divided by 3. So similarly 70, so you have to find a number which can divide, which divides 70 and 125, but they leave the remainder 5 and 8. We don't want that. We want to find the greatest number which can divide any two numbers perfectly. So in order to get that, you have to first, the minute you see greatest number and leaving remainder kind of question, get the actual numbers, and then what they are asking is find out a number which can divide 65 perfectly, and also find the same number should also be able to divide 117 perfectly. So x cannot be a bigger number, x has to be a smaller number, and if it is a smaller number, then it is going to be your HCF problem. Okay, if what you are finding out, if the required answer is less than the given data, then it is going to be a HCF problem. So if you find out the HCF of 65 and 117, you will be able to find the greatest number which divides the two given numbers respectively. Okay. Okay. Did you understand now? So get me the HCF for 65 and 117. Can you? What is the HCF of 65 and 117? Is it 13? Okay, let us, you have to first do the prime factorization of 65. So for the prime factorization of 65 will be 3 and 13, right? No, 5 and 13. So the prime factorization of 65 will be 5 multiplied by 13 is 65. And for 117, what would you get? What are you getting? The prime factorization of 117? Yeah, 3 square multiplied by 13. Correct? So the HCF will be take the lowest power. So before that, probably we can make the factors equal 5 to the power 0. So it's nothing but 3 to the power 0. Take the lowest power, 5 to the power 0 multiplied by 13. So what is the answer you're getting as? HCF is 13 is the largest number which can divide 65 and 117 perfectly, or you can say 13 is the largest number which divides, when it divides 70 and 125, it leaves the remainder 5 and 8 respectively. Okay, so either ways 13 is your correct answer. Have you all got it? Yes. Now let us try to increase our speed, okay, a bit in the next question. Have you all completed? Can we move on to the next question? Yes, okay. Yeah, the question is an assertion reason type question. For any two prime number P and Q, their HCF is 1 and the LCM is P plus Q. Now tell me, is this correct? Is this correct? Now see, the rules of the assertion reason time question will already be given to you, except for the last option, right? The first option is if both the assertion and reason are true and reason is the correct explanation of the assertion, then A. For B also, assertion and reason should be true, but the reason cannot be a valid explanation. For C also, assertion has to be true, but if assertion itself is false, what is the option then? If assertion itself is, there's only one option that you have to go for. Look at the assertion now. What is given? For any two prime numbers P and Q, HCF is always 1, that we know. But is the LCM P plus Q, or is it a product? When P and Q are prime numbers, the LCM will be a product of P and Q. Okay. So assertion itself is wrong. Then what is the option? If assertion itself is false, the option is D. Option D. Okay. Assertion is false. You don't even have to look at the reason at all. Okay, the option is D, right? Is it clear? But is the reason true? Is the reason true? It is given for any two natural numbers. LCM into HCF is equal to product of two numbers. R is true, right? Assertion is false. So always remember, whenever you have any two prime numbers P and Q, the HCF of any two prime numbers is always 1, and LCM of P and Q will be the product of the numbers P multiplied by Q. Is it clear? Yeah, assertion is false, but the reason is true, correct? Just a minute. Yeah. Okay, let's move on to the next question. Yeah, here. Two positive integers m and n are expressed as m is equal to p to the power 5 q square, n is p cube q to the power 4, where p and q are prime numbers. Find the LCM of m and n. Very easy question. Would you be able to do it? So n is nothing but p cube multiplied by q to the power 4. Find the LCM. LCM of m and n. So you have to take the highest power of all the factors. So p to the power, for p the highest power is 5 and for q the highest power is 4. Okay, highest power. You have to take the highest power of all the of all the factors. So the option is p to the power 5, q to the power 4, C. Let's move on to the next question. Let me know once you have done and we'll move on to the next question. Have you completed this LCM problem? Done. Okay. Let's move on to the next one. If two positive integers p and q are expressed in the form of 18, p equal to 18 a square b to the power 4 and q is written as 20 a cube b square, where a and b are prime numbers, you have to find the LCM of p and q. Can you do it on your own? Can you try it on your own? Okay. So do the prime factorization of 18. So this can be written as 2 multiplied by 3 square multiplied by a square multiplied by b to the power 4. And 20 you can write it as 2 square multiplied by 5 multiplied by a cube multiplied by b square. Let us make the factors equal. So here I would be adding a 5 to the power 0. Here I'll add a 3 to the power 0. And for LCM we have to take the highest power of all the factors. So the highest power of 2 is 2 square. For 3 it is 3 square. For 5 it is 5. For a it is a cube. And for b it is b to the power 4. Just multiply it. So you'll have 4 multiplied by 9 multiplied by 5 multiplied by a cube b to the power 4. So 9 4s are 36, or you can say 5 4s are 20, 180 a cube b to the power 4. So the correct option is B. Okay. Let me know once you're done. We'll move on to the next question. So okay. I'm sure these questions are very easy, and have you all completed? Diva, Darshana, have you completed? Sai Kriba, Deepu, yes, okay. Okay. Completed, very good. Let us move on. Can we move on to the next question? Okay. Yeah, this is something which I had to write because I was not able to take a print of it. Right. If a is nothing but 2 square multiplied by 3 to the power x, b, the prime factorization of a, b and c are given to you. And you are also given the LCM of a, b and c is 3780. Then what is x equal to? Do you remember us doing a similar question in the class? Can you do it? Can you do it and let me know? I'm sure you must be even remembering the answer, but I want you to do. Okay, so let us go on and do it. So A is nothing but you're given 2 square multiplied by 3 to the power x. B is nothing but 2 square multiplied by 3 multiplied by 5. Okay, and C is given as 2 square multiplied by 3 multiplied by 7. So let me make the factors equal. I'm going to add a 5 to the power 0 and 7 to the power 0 here. And here again, making the factors equal, I would like to know the LCM of A, B and C. Ideally, it should be equal to, it is given that it's equal to 3780. Okay, so when you take the LCM, you have to take the highest power. So for 2, the highest power is 2 square. And then for 3, we don't know what is x. Let's keep it as such. For 5, the highest power is 5. For 7, it is 7 equal to, let us do the prime factorization of 3780. So 2 ones are 2, 8s are 16. Okay, again 3, 5, and then again 3, again 3, 3 3s are 9, 3 5s are 15, and then 5 7s are 35. So when I do the prime factorization of the right hand side, the given value, that is 3780, the prime factorization is 2 square multiplied by 3 to the power 3 cube multiplied by 5 multiplied by 7. So when I equate it, 2 square gets cancelled, right? 5 gets cancelled, 7 and 7 gets cancelled. So 3 to the power x, or some unknown, right? It's possibly some unknown, x is equal to 3 cube. So therefore, when you equate the bases are equal, so the exponent would be x is equal to 3. So the option is C. Okay. Any doubts so far? Let me know once you're done. We'll move on to the next question. So I've got 30 questions and let's try to complete it before 7. Okay, 15 questions from each chapter. Let me know once you're done. Okay, probably you joined late. I've done it? Okay. Let's move on. Okay, Darshana. So always remember, whenever you have to take the least common multiple, take the highest power of all the factors. I'm again going to write it here. Take the highest power of all factors. Okay. But for HCF, what you have to do? Lowest power of only the common factors. But for the LCM, you have to take the highest power of all the factors. Okay. Can we move on to the next one? So here it's kind of, these are the kinds of questions which are expected from LCM, HCF, LCM and HCF topics, which is coming under the fundamental theorem of arithmetic, MCQs. So these are the questions that have been asked earlier. Let us move on to the, I hope all of you have completed, right? Now this is a question which uses the formula. You are given that the HCF of the two numbers is 40. For the same set of two numbers, the LCM is given as 252 multiplied by k. Find the value of k. A very good question. You have to use the formula. What is the formula? The formula is nothing but the product of HCF and LCM is always equal to the product of the numbers, if the numbers are A and B respectively. So HCF is 40, LCM is nothing but 252 multiplied by k equal to, what is A and B? 2520 multiplied by 6600. So k is equal to 2520 multiplied by 6600 whole divided by 40 multiplied by 252. Very easy. So 0 gets cancelled, 252 gets cancelled. So you have 6600 divided by, the denominator only has a 4. So just divide it. Let me know what is the answer. So 6600 divided by 4. 4. Okay. 5s are 20. So what is the answer? You should be getting K as 1650. Let me know if you're getting it. The option is, the correct answer is A. Yes, correct. Okay. If you have got well and good, it's just a revision of, okay, it's just one of the important concept here. Product of two numbers is equal to the product of their HCF and LCM. It is valid only for if the product of if the number of if the set of numbers are 2. Okay, it's only valid for two positive numbers, not more than 2. Let's move on to the next question. I'm just assuming that you have all completed. Yes, here is the question. Find the LCM of the smallest prime number and the smallest odd composite number. Which is the smallest prime number? The smallest prime number, the smallest prime number is 2, and the smallest odd composite number. Can you tell me what is the smallest odd composite number? So if you take composite numbers, the very first composite number, which is the smallest odd composite number? 9. Very good. Right. The smallest odd, because 8 is also, but 8 is even. 6 is also even. So the smallest odd composite number is 2. I'm sorry. Smallest odd composite number is 9. Prime number is 2. Okay. So smallest prime number is 2. Smallest odd composite number is 9. What are 2 and 9? 2 and 9 happen to be? What are 2 and 9? What is the LCM of 2 and 9 is what they are asking. LCM of 2 and 9. It's supposed to be the product of the two numbers. Okay, so the product of 2 and 9, which is 18. So your answer is B. That is your 18 is the correct answer. Now tell me a question. What are 2 and 9? Are they co-prime as well? Are they co-prime? What is the only common factor among 2 and 9? What is the only common factor among 2 and 9? It is only going to be 1. 1 is the only common factor between 2 and 9. So they are also co-primes. Right? Yes. Right. So the LCM of 2 and 9 is going to be 18. Very good. Let's move on to the next question. So these are the years when they have been asked. April 2024. Let's move on to the next question. Yes, I think now this is a similar question and you will be able to do it and let me know. Find the greatest number which divides. You are given two numbers leaving the remainders 5 and 7 respectively. The very first thing to do when you are asked greatest number which divides two numbers leaving remainder, the first thing to do is find the actual numbers. 281, 1249. Subtract it with the remainders 5 and 7 respectively. Get the actual numbers. Get the actual numbers and then go ahead do the HCF. Oh, super. Very good. Yeah, good. So what is 281 minus 5? 276. What is 1249 minus, it's 1242. Right? You have to find the greatest number which divides these two numbers, the actual numbers, perfectly. So always a number which divides the given numbers means they are asking for a smaller number, and if the required answer is smaller, it is going to be the HCF. So find the HCF of, you do it and tell me, HCF of 276 and 1242. Do it and tell me. Take your time. So for 276, Tell me the prime factorization. Let me also do it. So 276, the prime factorization should be 2 square multiplied by 3 multiplied by 23. Sanvi, are you also here? Is Sanvi also here? Let me know what you're getting, okay? So 1, 2, is it 130? That's the right answer. Yes. 1, 2, 4, 2. The prime factorization should be 2 multiplied by 3 cube multiplied by 23. So you should be getting an HCF of 2 multiplied by 3 multiplied by 23. So 138. Are you all getting 138? Yes, okay. Yes, 138 is the correct answer. Oh, super. What is that cup? Diva, I don't understand that. Oh, you did it first. Is that the reason why you are showing the gold cup trophy? Diva? Probably it's because you... nothing, man. Just an emoji. Okay. Let's move on to the next question. No, because we both got the same thing. Okay. True. Because she was the one who told the answer correctly, so she got herself a trophy. 138 is the right answer. Very good. It's a good thing to revise. Now, it's one of the easiest problems again. Let me see who does it first. Find the LCM of the three numbers 28, 44 and 132. Quickly do the prime factorization and take the highest power of all the factors and let me know what's the answer. 28, 44, 132. So you have to find the LCM of the three numbers. Do the prime factorization slowly, correctly, very carefully. So 28 is nothing but 4 into 7. So 2 square multiplied by 7. And then for 44, it is 4 into 11. So 2 square multiplied by 11. What is for 132? I think it is 2 square multiplied by 3, 12 into 11 is 132. Yeah, what is the answer? Is it 924? Absolutely right. Absolutely right. 924. That's the right answer. Superb. Very nice. You're working on your speed. You're really being very fast. All of you are very faster than me. 924 is the right answer. What is your doubt? Very good. Yeah, Deepu, Diva, later on tell me, okay, how you got those beautiful emojis, which I don't know. Is it from those? Later on tell me, right? Just to get myself live on YouTube itself was a little bit of, I had a hiccup and somehow I got here. So, anyways, the others, what is the difference between HCF and LCM? Very good question. See, the only difference between, can any of you tell me what is the difference between HCF and LCM? Let me tell to the child who is asking, the student who is asking me. See, whenever, for example, listen carefully. Suppose you have two numbers, say 8, and say you have another number, say 4 or 16, right? This is the same example that I always take. So when you take the factor, the student who is asking me the difference between LCM and HCF, please take care, okay? I mean, just listen here. So the factors of 8 are, what are the factors of 8? It's 1, it's 2, it is 4. and then 4 2s are 8 and then 8. These are the factors of 8. Right? For 16, what are the factors? You have 1, you have 2 8s are 16, you have 4 4s are 16, again 8 2s are 16, and then 16. These are the factors of 16. Okay, so what do you mean when I say factors? Is nothing but these are the set of natural numbers that can divide 8. Okay, the set of natural numbers that can divide a given number perfectly, that can divide a given number, they are called as factors. So for 16, these are the only numbers which can divide. 16 divided by 1, 16. 16 divided by 16 is 1. 16 divided by 8. So these are the natural numbers which can divide 16 perfectly. Okay. Among these, what are the common factors? You see, 1 is a common factor. 2, 4. 1, 2, 4, and even 8. These are the common factor. Among all the common factors, if you see, 8 is nothing but the highest number, largest or greatest or biggest number which can divide both 8 and 16 perfectly. So 8 happens to be the highest common factor. So HCF is nothing but 8. The greatest number which can divide a set of given numbers perfectly. Okay, that is the HCF. So whenever you are finding the HCF, what you are trying to find out is the biggest number which can divide. It's the largest number. You cannot have a number bigger than 8 in our case. So you cannot find a number bigger than 8 that can divide both 8 and 16 perfectly without leaving a remainder. What about LCM? Suppose I have to take, say, multiples, right? 4 and 8 respectively. Write the multiples of 4. So 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16, 20, 4 6 are 24, and so on. For 8, if I have to write the multiple of 8, it is 8, 8 2s are 16, 3s are 24, right? 8 4s are 32, and so on. 40. So these are the, what am I writing? All these numbers are divisible by 4, right? Multiples of 4. What do you mean by multiples? Let me write it here. Multiples of 4. These are multiples. If you are asked to write the multiples of 8, 8, 16, 24, these are nothing but all these numbers are divisible by 8. Now, among all the natural numbers which are divisible by 4 and 8, if you take the common multiple, right? If you take the common multiple, which are they? 8 is common, 16 is common, 24 is common. In all the common multiples, which is the smallest number, which is the lowest number, or the least or the smallest number which is divisible by both 4 and 8, it is 8, right? So this is nothing but you take it as a least or lowest common multiple. So what do you mean by LCM? LCM of a given number is the lowest number which is divisible by a given set of number. Whereas HCF is nothing but the biggest number that can divide a given set of numbers. So that's the difference between LCM and HCF. I hope that answers your question. Okay, let us move on to the next question. Sorry. Yeah, here. Read it thoroughly. What is the assertion statement? The assertion statement is, yeah, thank you, welcome. The number 5 to the power n cannot end with the digit 0 where n is a natural number. And the reason is prime factorization of 5 has only two factors, 1 and 5 respectively. Now tell me, okay, now tell me, what is the correct answer for this? Any number that ends with the digit 0 should have at least one factor as 2 and one factor as 5, correct? But if you take 5 to the power n, it will have only 5 as a prime factor, right? 5 to the power n, you cannot prime factorize, you cannot break down 5. 5 is a prime number, so it's always going to be 5 to the power n only. Okay, it does not have 2 also as a, so 5 to the power n has only one prime factor, which is 5. But if it has to end with 0, it should also have what? 2 as its prime factor. So, what is it? It's given 5 to the power n cannot end with the digit 0. It is true. A is true. Assertion is true. What about the reason? Prime factorization of 5 has only 2 factors, 1, and that's also correct, right? If you do the prime factorization of 5, but what is the option? What do you think is the option? Is your reason the correct explanation for your assertion or not? Okay, initially we have understood, right? 5 to the power n cannot end with the digit 0, right? Where n is, because in order for 5 to the power n to end with 0, it should also have 2 as also its 2 also should be one of its prime factor. But then 5 to the power n only has one prime factor, which is 5, right? So this is correct. Assertion is true. What about reason? Reason is also true. Prime factorization of 5 you can write it as 1 into 5. 1 and 5 are the only prime factors. But is reason the correct explanation for assertion? What do you think it is? Reason is not the correct explanation for the assertion. Okay. So what is the option? The option is B. What does B stand for? B is nothing but, if you are given, could you explain assertion? Ma'am, I cannot understand. Oh, super. Okay. Look here. See, you are given in the assertion, look at the statement. The number 5 to the power n cannot end with the digit 0. Okay. Whenever you have any number which ends with 0, okay, if you do the prime factorization, what you get is any number which ends with 0, it should always have 2 as well as 5 as its prime factor. Okay, whenever a number has to end with the digit 0, any number which is ending with 0, its prime factorization will definitely have 2 and 5 as its prime factor. What is given in the assertion is 5 to the power n cannot end with the digit 0. It is true, because when you take 5 to the power n, 5 is the only prime factor. It does not have 2 as its prime factor. So, it can never, 5 to the power n, right? 5 to the power 1 is 5. 5 square is 25. What is 5 cube? Again 125. It will always only end with 5. It can never end with 0, because in order for a number to end with 0, its prime factor should be, one of the prime factors should be 2 and the other prime factor should be 2 and 5 are compulsory. So, because 5 to the power n does not have 2 is not there, right? 5 to the power n does not have 2 as its prime factor. So, what the statement says is it cannot end with the digit 0, which is true. It is true. The second reason is also true. The prime factorization of 5 has only 2 factors. So, if you take 5 as a number, there are only 2 factors, 1 and 5 respectively, right? So, R is also true. But R is not the valid explanation for, R is not the correct explanation for assertion. Is it clear now? Okay. The reason what they are saying is, they are just saying the prime factorization of 5. They are just telling you 5 has 2 factor 1 and 5. But that does not explain why 5 to the power n cannot end with the digit 0. No. What the reason should have been? The reason should have been, for a number to end with 0, 2 and 5 should be one of its prime factor. If that was the reason, then your option would be, what would be your option in that case? Both assertion and reason are true and reason is the correct explanation, then the option would be A. Okay, if the reason was that for a number to end with 0, 2 and 5 will definitely be one of its prime factor. The prime factors will be 2 and 5. If that was the reason, the option would be A. That means, what does option A mean? Assertion and reason are true and reason is the correct explanation for assertion. But what is the reason given? It is a totally different reason. They are just telling you 5 has 2 factors, 1 and 5. Is it clear now? Is it clear now? To say 5 has 2 factors, 1 and 5, how is it even related to you understanding or you telling that 5 to the power n cannot end with the digit 0? So, you should talk about 2 and 5. Okay, whenever you are dealing with a number ending with 0, your focus should be that any number ending with 0 should have 2 and 5 as its prime factor. But nothing of that is mentioned in the reason. So, the correct answer is, what do you think is the correct answer? B. Option B is the right answer. What does option B state? Option B states that both assertion and reason are true, but reason is not the correct explanation for the assertion. Is this clear? Is it clear now? Okay. I hope it is, yeah. Now, moving on to your polynomials. Find the zeros of the polynomial p of y you are given. Let's find the zeros of this polynomial. Can you try it? Find the zeros of the polynomial. P of y equal to 7y square minus 11 by 3y minus 2. Let me do it for you. Just a minute. Just give me a minute. First of all, take the LCM. Okay. Take the LCM. So what does P of y become? Your P of y will become, take LCM 3. Okay. So you will have 21y square minus 11y minus 2. And if you have to find the zeros, you have to equate it to 0. Correct? Take the LCM, make sure, and then, 3 would become 0 if 3 goes to the, if you cross multiply. What will be left is 21y square minus 11y minus 2 is equal to 0. What is the sum and what is the product? The sum will be your B and product will be A multiplied by C. A into C will be a product. So the sum is minus 11 and your product will be 21 multiplied by minus 2, which is minus 42. Minus 42. Okay. Yeah, let's do it. You just have to find the zeros. Okay. You have to just find the zeros of it. You're not asked to find the sum and product. You have to just find the zeros. Okay. Yeah, alpha and beta is what you have to find. So what will we do? We will use a method which is called middle term splitting. For which question are you asking to use trial and error method? Is it for this question or for the previous question? Okay, so the one we are currently doing. No, never use trial and error, because you have to do a factorization. You have to find the zeros of the polynomial. You have to use middle term splitting. No, that will be more time consuming if you have to try with each of the zero. Okay. The easiest method is to find the zeros. Okay, do the factorization using middle term splitting. So what are the two numbers? Can you tell me which are the two numbers? So how do you find out the two numbers whose product should be minus 42 and sum will be minus 11? So do the prime factorization of 42. So 2, 2, 21, 3, 7, right? So which are the two? 14. 7 2s are 14 and 3, right? If you put a minus 14 plus 3 will give you minus 11, and minus 14 multiplied by 3, product will be minus 42. So always do the prime factorization of 42 and see which combination works well. You cannot take 6 and 7 because that will give you 13, right, if you add it up. So see the other combination. 7 into 2, 14 and 3. 14 and 3 will give you a minus 11. Let's do the middle term splitting. All of you do it with me. So 21y square minus 14y plus 3y minus 2 equal to 0. Take 7y common out. So 3y minus 2 plus 1, 3y minus 2 equal to 0. So take the common, 3y minus 2 is common. The other terms are 7y plus 1 equal to 0. Okay. So what are the zeros here? Now you can easily find out, right? So for the given question, I hope you have written the question. Either 3y minus 2 is equal to 0, which means y is equal to 2 by 3. This is one of the 0, or 7y plus 1 equal to 0. So 7y equal to minus 1. Y is equal to minus 1 by 7. Okay, so these are the zeros. Let one be alpha, the other one is beta. So 2 by 3 and minus 1 by 7. The option is option D. Let me know if you have got it. Do it yourself. The zeros of the given polynomial are 2 by 3 and minus 1 by 7. Have you got it? Yeah, sure. Definitely. Okay, Deepu. Sure. Probably we'll have this regularly, okay? Almost on all Sundays evening. Probably for 45 minutes. Okay, bye. Thank you. What about the others? Yeah, sure, Deepu. Sure. Sure, Diva. We will continue. See you all in the class tomorrow morning. Thank you. Yeah, you can leave. You can leave now. Yeah, bye. Can we continue for the next question? I hope the others have done it. Yes. Okay, we'll do one more question and then we'll wind up, okay? So here, find the zeros of the polynomial p of x is equal to, so whenever you have square root, usually it's a little tricky. Can you try it yourself? So let me tell you, here you have to find the zeros using middle term splitting only. Okay, so you are given the polynomial and you have to find the zeros. So x square minus 3 root 2x plus 4. Whenever you have to find the zeros, you have to equate it to 0. What should be the sum and what should be the product? The sum should be your b value, right? B is nothing but minus 3 root 2. Minus 3 root 2. And your product is nothing but the coefficient of x square and multiplied by a into c. Okay, a into c is nothing but your 4. Okay? So listen carefully. The product should be 4 and the sum should be minus 3 root 2. So if I write like this, 2 root 2 and root 2, right? Root 2 into root 2 is going to be 2. 2 into 2 is 4. Okay. And where should I put a negative sign such that I get a sum of minus 3 root 2? Can you tell me? So it should be minus 2 root 2 and minus 2 root 2 minus root 2 is going to be minus 3 root 2. Minus into minus will be plus and the product will be 2 root 2 into root 2 is 2 into 2 4. So when you do the middle term splitting, okay, you are getting x square minus 2 root 2x minus root 2x plus 4 equal to 0. Take x common out, you will have x minus 2 root 2 minus again root 2 common out, x minus 2 root 2 equal to 0. X minus 2 root 2 is one of the factor and x minus root 2 is the other factor, is equal to 0. So either x is equal to 2 root 2, this is one of the product, or x is equal to root 2. So these are the zeros of the given polynomial, 2 root 2 comma root 2. So the option is B. Okay. So this is the correct answer. Let me know once you have completed, because there are so many questions that we will be doing this week with respect to finding the zeros of the polynomial. Okay. Let me know once you have completed. So always remember, find whenever you have to find out, check the product, okay, and make sure you're getting the sum as well. So the sum should be your B and the product should be A multiplied by C. Yeah, okay. I think we'll pause here and we'll continue the remaining in the next our regular class or probably next week. Okay. Thank you so much for joining in. We'll end the live session right now. Thanks a lot. I hope it was useful. Was it useful? A little practice, right, of the topics that we have already done in CH1, CH2. I do have more questions to do, but we'll probably continue it in the next session. Okay, thanks. Yes, okay. Thank you so much. You can leave. Thank you. See you all in the class tomorrow.